So we want to be able to identify H and K. So I don't have to switch colors back and forth a bunch of times. I'm going to do all the H's first. Okay, so H is what is subtracted from X in the denominator. Here, nothing. H is 0. That means that my vertical asymptote is at X equals 0. So I can draw that. I've got a vertical asymptote at X equals 0. Here, my H is 2. So that means I've got a vertical asymptote at X equals 2. Oh, thank you. Sorry. Okay, and then in 3, your H is 3. So you've got a vertical asymptote at X equals 3. Okay, then I'm going to do the same thing with my K and identify my horizontal asymptote. So the K is what's added or subtracted on the outside. Here, that's nothing. Here, that's nothing. So both of these that are 0, that just means my horizontal asymptote hasn't moved from the parent function. It's still at y equals 0. Now this one, it was shifted up to 1. Now, to get the points to plot, you can use Desmos, or you can just pick a test point to the left and the right of each of those to check and see. Okay, that's up to you. How, if you want to use Desmos or check them by hand. Okay, so in this first one, to the left, I would just choose -1. So that would become -1 plus 1 is 0. So -1, 0. Okay, and then to the right, if I plugged in a 1, that would be 1 plus 1 would be 2. So 1, 2. So those curves should have been top right and bottom left. And that would confirm, you could confirm that in Desmos if you needed to. Now, you should be able to answer these domain and range questions before even sketching those. As soon as you identify that, I'm going to finish this because I'm recording. So if we don't finish it before you go, that's okay. But you can identify domain and range without even drawing the curves. As soon as you know your asymptotes, you know your domain and range. So your domain for this first one, remember the domain is determined by the vertical asymptote. So it is from -infinity to 0, union 0 to infinity. And the range is based on the horizontal asymptote. So it's -infinity up to 1, union 1 up to infinity. Y'all are good. I'll see y'all later. I'm going to finish this video. You can check it later. Okay, so same thing here. I'm going to just go ahead and give the domain and range without even knowing what sections the curves are in, because it's just based on those asymptotes. Okay, so the vertical asymptote's at 2. So it's -infinity to 2, union 2 to infinity. Here that break is at 3. Same thing for the range. Here that break is at 0. Same thing here at 0. Now we'll go ahead and check some points to go ahead and graph on these others as well. So for this one, a point to the left, I'm just going to check 1. So if I plug in a 1, minus 2 is -1. So -2 divided by -1 is +2. 1, 2. Okay, and then a point to the right. So we could check, for instance, 3. So 3 minus 2 is 1. So that would just be -2. And then you could go through that point and use the asymptotes to guide in behavior of your curves. Okay, if I checked a point here, I could check 2. If I plug in a 2, that'd be -1. -1 over -1 is +1. Okay, and then if I checked here, 4 would be 1, that would be -1. Now, instead of checking points, if you understand that your A value being positive versus negative, the reflection will tell you what, if it's top right, bottom left, or top left to bottom right. See here, A was positive, so it was like the parent function. But in these, A was negative, so it was reflected, and it was top left, bottom right instead. So you could use that to determine which sections created by your asymptotes that your curve belongs in as well. All right.